Sorry, folks. Okay, once again, I'd like to take the time to thank you all for attending today's presentation. My name is Lance Zurich. I'm the product manager here at the fischertechnik Education Division at Studica. And I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, if you're a college professor or an industrial trainer teaching programming skills required in manufacturing, maybe you're with a company looking for ways to demonstrate your software-based solutions, or even just someone who's looking for ways to make IoT-related concepts easier to understand to employers or customers. In any case, I believe this presentation is going to offer some important options for you to consider. And we're going to start off by considering the skills gap. Now, if you've attended any of our other fischertechnik education webinars, you've probably heard me discuss the importance of STEM education. And STEM, of course, is an acronym which stands for science, technology, engineering, and mathematics. And at this point, it should really go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help best prepare them to take their place in the modern workforce. Not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing has become more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas like mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions that we're going to be looking at in this presentation, let's consider that last skill area I just touched upon, that of being a PLC programmer. Well, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. And essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes that are typically found in an industrial setting, such as, for example, an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of systems like this grows exponentially. And to get just a pretty clear idea of just how highly prized these kinds of programming skills are, I'm going to give you some salary figures for PLC programmers as quoted from the job search website, NineVolt.com. Quote, the average PLC programmer's salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, at the time that I was preparing the original version of this webinar, I took a look at the listing of current job openings for PLC programmers in NineVolt.com, and this was back in 2020. And the listings at that time showed 15 different positions being advertised with salaries of over $75,000, and two of which even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. But at the same time as this, what you would call this workforce of tomorrow is getting their training, more and more manufacturing companies who face an urgent need right now are enrolling their incumbent workers into private training schools offering programs like this. So the question might be, how long does it take to learn these skills? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed on the screen right now, as well as learning how to efficiently troubleshoot and address errors in judgment and equipment breakdowns, more training, of course, would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, many other options available, things like high school CTE, career and technical education training programs. There's, of course, adult continuing ed programs, vocational training, technical training and trade schools, and employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, and this is whether you're in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and hands on? But there are other areas of focus beyond programming that also need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be that it's a company involved in the creating or marketing of a new type of software based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for ways to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or it could even be a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and there are, of course, more, there's a need for finding a solution that is engaging and which can effectively mimic and simulate real world automated systems. And that, of course, brings us to the fischertechnik line of industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands on method for teaching and demonstrating high end automated systems. The line consists of a series of pre assembled small scale models which are designed to replicate in both appearance and in function various automated robotic machines and systems commonly used in commercial manufacturing. But before we begin to look at each of these models, I'm going to provide you with a little bit of a background on fischertechnik. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, with the fischertechnik system, it was created with more of an engineering mindset. The core building block in this fischertechnik system is designed to enable attachment from all six sides, like you see in the graphic on the screen. And because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of different parts available will also help to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who you see here, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949. And he was also the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, and that's whether we're talking about those sets intended for retail market or those used for the classroom. The focus of these sets has always been on helping people to understand how technology works. Many of the products offered by fischertechnik for the education sector are what we would refer to as subject-specific sets, for example, focusing on different STEM-related areas such as mechanics or pneumatics, robotics, renewable energy, or what have you. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system and then perform various experiments which allows them to explore and understand these various aspects of that subject. There are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process, which also requires them to work in groups and create various devices and automated machines to meet the criteria being put forth in a series of real-world style scenarios, all based upon their own trial and error experimentation and research. Now, the line of fischertechnik simulation solutions, which of course are the focus of today's presentation, are something much different. The line consists not of kits, but again, of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Some of the models that you will find in the fischertechnik simulation line include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even Highbay warehouse storage systems. Now, besides these individual models, which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. Now, this model consists of 4 individual workstations. In this case, it's going to be a vacuum gripper robot, a high-bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which are designed to all work together as one self-contained material cycle. And of course, we're going to look at that a little bit later. Now, before we begin to look at the models in the simulation line in detail, I'm going to very briefly outline some of the advantages of using fischertechnik solutions. Now, I do apologize in advance, as a few of these things are points I've touched upon before, but in each case, I do think it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models are once again designed to realistically replicate, again in both appearance and in function, common automated systems, things such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop size, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next aspect is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each of these models is available in a 24-volt version designed for use with industry-standard PLCs. Now, it doesn't matter whether you prefer to use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric. Of course, there are many others. In any of these cases, you can control these 24-volt versions of the models with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the languages listed on the screen now. Please note that with these 24-volt versions, no PLC is included, and all programming and programming guidance, as well as any power supplies or hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. I will say in advance, there are a couple options that do include some wiring in PLC, which we will discuss later in the presentation. But most of them will require that you provide that on your own. Moving right along. In addition, for non-industrial users, or for those educators who aren't versed in or familiar with PLC programming, there are several models which are currently available in 9-volt versions. Now, these 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controller, which is called the Robotics TXT controller. And each of these controllers is pre-programmed using fischertechnik's own RoboPro programming software. Now, with these 9-volt models, the only additional component required will be some power adapters, which we will mention as we get into each model. Otherwise, in most cases, these 9-volt models are essentially ready to use out of the box. Moving along with our advantages. Now, if you're involved in demonstrating or exploring IoT, of course, which is also known as the Internet of Things, besides the fact that many end users we work with have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, besides this, fischertechnik now also offers a special IoT-focused variation of the factory simulation, which is designed specifically for exploring and understanding cloud-based control and what is often referred to as Factory 4.0. Now, in the case of these models, the model is designed to be both controlled and monitored from a special web-based dashboard, And of course, we're also going to discuss this in more detail in just a little bit. Finally, fischertechnik simulation models are cost effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options in the marketplace, you'll probably notice that the entry point for many of these products can easily be $30,000, $40,000, even much, much more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of that price, as well as, again, being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's take a look at each of the models which are currently available. The first model we're going to look at is the vacuum gripper robot, which you see on your screen now. Now, as you're going to see in this video, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model itself includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt version of this model, which is the only version available right now, as well as all of the first 5 24-volt models that we're going to be looking at today, each have a relay board for motor polarity reversal and both a multi-pin connector, which is 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as all 24-volt versions, will require you, the end user, provide the PLC and the program. I will mention that for this and for all the models that we're going to look at today, the specs are also detailed in the product listings, which are found on the Studica website. And there are also product brochures that we put up there and other information that's available for download. And of course, we're going to discuss that more as we end in the presentation. But if you do want to find out more information, visit our website, and there is material you can download on each of the models. And that was a vacuum gripper robot, or I should say the vacuum gripper robot. And next, we're going to look at the automated Highbay warehouse. Now, the model you're going to see in this video features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and along with a selection of different colored workpieces and carrier trays for each piece. Now, I will mention that this particular model is a favorite among educators that I've spoken with who are involved in teaching PLC programming. And the reason for that is because it gives you so much to work with in regards to, of course, the precise movements of the picker mechanism, as well as the precision required to properly store and retrieve each of these workpieces, each step which will, of course, require its own very specific coding. Getting back to specs, the dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Again, this 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming, and I will mention that there is a limited edition 9-volt version also available at this time, which is, again, pre-wired to a pre-programmed robotics TXT controller, and in that case, 1 power adapter is required. The next model we will look at is the multiprocessing station with oven. The model you're going to see here features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard version of the model is the 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal, and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And there is also a limited edition 9-volt version, which in this case comes connected to 2 robotics TXT controllers. So for this reason, 2 power adapters would be required. We'll let this just play out for another couple seconds. And there's our payoff. The next model we're going to look at is the sorting line with color detection. And we'll just turn that off. It always likes to go on. This simulation features a system for detecting work pieces of different colors, and it sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. And again, as with the models we've looked at earlier, the standard 24-volt version has a relay board for motor polarity reversal, and both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you do need to provide the PLC and the program. And there is a limited edition 9-volt version, which is currently available. And again, it comes pre-wired to a pre-programmed TXT controller, and 1 120-volt power adapter is required with that. The next model we're going to look at is the factory simulation. And again, this combines the 4 models we've just reviewed: the vacuum gripper robot, the automated Highbay warehouse, the multi-processing station with the oven, and the sorting line with color detection. Combines them all into one self-contained material cycle. And the cycle works like this that you're going to see. Work pieces are retrieved from the automated Highbay warehouse using the vacuum gripper robot, and then they're moved to the multi-processing station with the oven. And after the workpiece has been processed by the multi-processing station, it's then sorted by color in the sorting line with color detection before again being moved by the vacuum gripper robot to the automated Highbay warehouse for storage once again. Now, as we've already discussed the components of each of these models previously, I'm not going to belabor it by restating all those here. But what I do want to mention are the dimensions of this model as a whole. As it again combines these 4 individual models into one cycle, it has a much larger total footprint. In this case, it's approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, all depending upon whether we're talking about the 24-volt version or the limited edition 9-volt version, which is still available. Now, due to these dimensions, and due to the fact that, again, these models all ship pre-assembled, please note that this model will only be shipped flat as freight on a pallet. And I also do want to point out that as the factory simulation models, and that goes for these or a few that we're going to look at later in the presentation, all of these models are in very high demand. So because of that, I would ask that you please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. Few other things to note. First, this is currently available again in the standard 24-volt version, and again in very limited quantities in the 9-volt version. In the instance of the 9-volt version, it's wired to 5 robotics TXT controllers, but because of the way that some of the controllers are daisy chained together, it's only going to require 3 120-volt power adapters. Of course, as always, the 24-volt version will require the end user provide the PLC, the programming, and any other hardware required. And again, the stations of the 24-volt version use the relay board with motor polarity reversal in both the multi-pin connectors, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, the other thing I want to mention before we move on to the next group of models, we do have a storage option that's available specifically for either of the factory simulation models, either version, the 24-volt or the 9-volt version we just looked at, as well as some factory models we're going to be looking at later on in the presentation that go by the name of Training Factory Industry 4.0. This is really the way that you want to transport the model or protect it when it's not in use. The travel case itself consists of an aluminum case maker profile with plastic plates and steel ball corners, and it also has 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model. And it also has 3 internal pockets with storage for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. And the case itself has exterior dimensions of approximately 41 by 33 by 17 inches with a weight of approximately 53 pounds. And please do note that even when using the travel case, these models will still need to be shipped flat. Moving along, the next model we're going to look at is a very basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as you may desire. Components on this model include an XS motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. Now, as before, the standard 24-volt variation includes a multi-pin connector, but in this case, we're talking about a 26-pin connector with a 2.54 millimeter grid as shown here. And for a limited time, we still do offer a 9-volt version pre-wired to the robotics TXT controller as shown here. And again, one 120-volt power adapter is going to be required for use with this one. The next model is a variation of the conveyor belt, which also includes a punching machine. Now, this, again, features essentially the same conveyor as we just looked at, except this time with the machining station built onto it. Components on this model are going to include 2 XS motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in the standard 24-volt variation with the 26-pin connector, 2.54 millimeter grid as shown in this slide. And for a limited time, we are also offering the 9-volt version wired to the robotics TXT controller, and 1 power adapter is required with this. The next model is the indexed line with 2 machining stations. And this particular model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 XS motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in both the standard 24-volt version with the 26-pin connector and 2.54 millimeter grid for use with the PLC and programming of your choice, and in a limited release 9-volt version wired to the pre-programmed robotics TXT controller and requiring 1 power adapter with that. The next model we're going to look at is a variation on the idea of a pick-and-place robot, which is the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 can turn 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model as a whole are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And again, it comes in either the 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed for use with PLC and programming of your choice, or in the 9-volt version, which in this case is not a limited availability model, but is a standard model. And once again, this comes pre-wired to the pre-programmed robotics TXT controller, and it requires one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. Now the next pair of simulation models are designed to focus specifically on the area of IoT and are designed for demonstrating and teaching about cloud-based monitoring and control. And these models go by the name of Training Factory Industry 4.0, which are available in both the 24-volt version for use with PLC and also a 9-volt variation for classroom and demonstration purposes. Now, these models have been designed to help address how the recent changes in industrial production, which are all driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, which we saw earlier, such digitization activities can be simulated, learned, and applied on a small scale before they're implemented on a larger scale. Now, as the following video showcasing the 24-volt version of this model provides a nicely narrated overview of just how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
customized storage and transport case.
Well, I hope you found that interesting. I'm just going to give a little bit of review of some of the main points. First off, the following topics can all be addressed with the fischertechnik Training Factory Industry 4.0. First off, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models that we previously discussed, besides most notably the use of the cloud-based dashboard for monitoring and controlling the model. Now, some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, and also the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, and enables the positions of each workpiece in the work cycle to be mapped. And also the use of MQTT, message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. Now, as there are two variations of the model, let's go over what makes them different aside from the voltage requirements. And we're going to begin by focusing on the 24-volt version and what makes it unique. First off, it is a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one fischertechnik Robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud-based dashboard. Communication between the PLC and the TXT controller is carried out using an IOT Gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is of course a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node Red. And this allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, but also being able to display data and calibrate the stations of the factory in a Node Red dashboard. The model also incorporates newly developed 24-volt adapter boards to interface with the PLC, and these, of course, do ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM or pulse width modulation. And they also have push-pull output stages for photo transistors and for buttons. Finally, one of the most important new features. Now, unlike any of the previous 24-volt models that we discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a special sample program. In this case, the sample program was designed to be in structured text format, ST, and it was created based upon a Siemens S7 1500 PLC. And this is, of course, available for download on GitHub. Now, as the new training factory can also be controlled with other PLC models and brands, you can easily make some adjustments using the sample program, and source code for all of this is available for download as well from GitHub. Now, as with the first of the 24-volt models, we looked at the Training Factory Industry 4.0 model as a relay board for motor polarity reversal in both the multi-pin connector, in this case it's the 34 pins with a grid of 2.54 millimeters, along with PCB terminals with push-in connections for all inputs and outputs. And all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website, from our own website, or if you'd like a copy, you can email me. I'll give you information on that at the end, and I'd be happy to send you a copy as well. Now, moving along to the 9-volt version, in this case, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions that we looked at today, in this case, this one is programmed not using the RoboPro software, but instead using C, C++. Again, all the programming with these 9-volt versions comes preloaded, so that once the connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation PDF, which is also available for this model, you can be able to get started pretty quickly once you do that. The 9-volt version will require the addition of 3 120-volt power adapters. Of course, both of these models require the ability to access the internet and also a tablet or a device for accessing the cloud-based dashboard. So that, of course, you do have to provide. The dimensions for these models are approximately 39 by 31 by 16 inches, and they have a total weight of approximately 51 to 53 pounds, depending on the version. As with the 2 factory simulation models, which we discussed previously, we do recommend the optional travel case to help protect your model during transport or storage. And that is the Training Factory Industry 4.0 model, now available in both 9-volt and 24-volt variations. So, of course, you might be wondering, how much do these models cost? So we're going to take a quick review of each option I've discussed, along with the pricing for each. First off, the vacuum gripper robot is available in the 24-volt version only, and that is $1,129.95 per unit. The automated Highbay warehouse is available in both versions. There's the 24-volt version for $1,369.95, and the 9-volt version with the TXT controller is $1,318.95. The multiprocessing station with oven in the 24-volt variation is $1,199.95, and in the 9-volt version with the TXT controller is $1,474.95. The sorting line with color detection in the 24-volt version is $1,049.95. In the 9-volt version is $1,128.95. The full factory simulation in the 24-volt version is $4,829.95, and the 9-volt version with the TXT controllers is $5,239. The conveyor belt in the 24-volt version is $324.95, and in the 9-volt version is $518.95. Again, that comes with the TXT controller. The punching machine with conveyor belt in the 24-volt version is $419.95, and in the 9-volt version is $599.95. The 3D 3-axis robot in the 24-volt version is $999.95, and in the 9-volt version is $1,369.95. The indexed line with 2 machining stations in the 24-volt variation is $1,129.95, and in the 9-volt version is $1,394.95. As for the Training Factory Industry 4.0, the 24-volt version is $8,999.95, and in the 9-volt version with the TXT controllers is $9,024.95. But we do have 2 new variations of the Training Factory Industry 4.0 24-volt version, which are also available. These became available late last year. There is a version that has the PLC connector board. So what this essentially means is the wiring, which normally you would have to do for any of these simulation models, from the model itself to the PLC, that's all included. So you have your wiring from the model to the PLC is included, and you can get that variation for $12,079.95. Or if you would like a version that includes that as well as the Siemens PLC, in this case it's the PLC S7 1500, so pretty much the full model with the wiring, the connection board, and the PLC. If you're looking for the educational version, this is only available to academic institutions, accredited academic institutions. The pricing for that is $18,499.95, and the commercial version for everyone else is $20,124.95. Other items that I've touched upon a few times: the 120-volt power adapters that are used with the 9-volt models, and in a couple cases with the 24-volt Training Factory Industry 4.0s to power the TXT controllers that I mentioned on those. Those are $12.99 each. The travel and storage case, which again is used for only the factory simulation and the training factory industry 4.0 models, that is $1,524.95 per unit. So on that note, if you have any questions, this would be your chance to use the Zoom chat window or the question window, both of which you will find access to on the Zoom toolbar. So if you do have any questions, any comments, anything that you might like to know, this would be your chance to type it in and ask. And if I don't see anything come up, I will move along quickly because I will give you another way to ask questions. So if you'd like to take the next step, if you would like to, let's say, request a full color brochure with the current pricing, we can provide a price list to you. If you'd like to ask any questions directly, if you'd like to request a quote for any of the things that you've seen today, or if you'd like to speak with your dedicated educational representative, you can do all of this by calling us directly. Our number here at Studica is 888-561-7521. Once again, we're located in the US. That's a toll-free number, 9 a.m. to 5 p.m. Monday through Friday. We will answer your call, 888-561-7521. If you have general questions, you can email us at info@studica.com. Or if you have any questions about any of these models that are of more technical nature, anything you might like to ask me, anything that I touched upon today or that you were hoping I touched on, you can also email me directly. And my email is lance.zurek. That is lance.zurek@studica.com. So on that note, I'd like to thank you very much for taking the time to attend today's presentation. I hope you have a great day, and we look forward to hearing from you soon. Thank you and take care.